Have you ever considered how your eye scans across a landscape? I think most people assume that, like a video camera, it pans smoothly across the scene. But I don't actually think that's what happens. In truth, I think the eye jumps from image to image as it moves across this scene. So I'm going to try to find a volunteer to help me demonstrate that. What I'd like you to do is scan across this landscape as smoothly as you can. Can you try that? Tell me about the process of scanning across, from the point.
It just feels like you're stopping and going, and then like stopping and going, and
yeah, it just feels like there's a pause all the time, constantly when you're going across. It's not like you're just looking straight across.
yeah, it's not smooth.
The eye is capable of tracking smoothly, however. If something moves across your field of view, your eye can lock onto it and move smoothly with it. What I'd like to do is, I'd like to repeat that little game, but I would like to ask you just to walk across on those rocks, and then I'd like you to follow her along with your eyes.
Okay.
Is that possible?
Yeah.
Okay, let's give it a shot. Do you want to go over
Okay,
there?
yeah.
Okay. All right, go. Yeah, go for it. Can I just get your reaction on what that was like? How was that the same or different?
That felt a lot smoother because I was following something instead of just looking at something. Yeah, I don't know, just like if you follow something, your brain focuses on that one thing and you just kind of just go with it.
Why would that be useful, to be able to pan with a moving object? How does that affect our perception of motion? Well, I think it makes most motion seem quite smooth and makes it more difficult for us to determine when things are accelerating. One last question since I've got you guys here. So what I want to do is I want to drop the ball. I want you guys to watch it and then tell me how the ball moved.
Okay.
Is that fair enough?
Okay. So you want us to watch it till it gets
Watch it till it hits the ground.
Okay.
And then afterwards you're going to tell me how it moved. Okay, 3, 2, 1. I'll do it just one more. 3, 2, 1. Could you tell me about the motion of the ball? What was it doing as it went down?
It's fast.
I don't know, it just seemed like it just dropped. Like it wasn't even moving. You just seen the ball drop to the floor and that was it.
You didn't see it like here, you just saw it from there to there.
Yeah.
Would you say its speed was constant, or do you think its speed was changing?
Constant.
Yeah, it was the same.
Yeah.
The whole way down?
Yeah.
No acceleration. The goal of my whole experiment today, I'll let you guys in on the secret, is to point out that the eye tracks motion very smoothly. So when the ball goes down, it's really easy for us to track that.
Yeah.
And it looks like it's just doing one constant thing. But in fact, it is speeding up the whole time. When I release it, it's not moving at all. And when it hits the ground, it's actually going quite fast. So that was kind of my point. If you scan across like a stationary scene, then your eye's doing this weird jumpy thing.
Yeah.
But then if you're actually moving with an object or with a person or something, then your eyes are so smooth that you don't even notice.
Yeah. But something that's still and you have to move, that's when it starts to jump. But if there's something moving, your eyes have to follow that. It's much easier. Yeah, I understand.
Excellent.
Now. Yeah.
What is a force? It seems to be an idea that a lot of people are confused about. It's like Star Wars is the only source of knowledge. What is a force?
It's like Jedi.
Like, force is how you raise X-Wings out of swamps. You just concentrate.
What would you say a force is?
Well, other than Jedis.
But outside of Star Wars, a force is energy and mass. So if you have a huge thing moving really fast, you got a lot of force. It's like getting hit by a truck as opposed to getting hit by this tennis ball.
Force is energy that comes from somewhere.
Something that exerts energy on all other matter.
The movement.
The movement of something in one direction and the atmosphere.
Listen.
I don't know. It's this indescribable thing that kind of keeps us from flying off into space. Nobody really knows what it's about. It's just a theoretical kind of thing.
And that should teach me to interview philosophy students. But contrary to what she said, there were some people who knew what force was about.
Something that makes something move
from its original position.
How you propel something, or how you get something to move, or how to reshape something.
It's a kind of attraction or direction or something like that
Like
an object has on it. Yeah.
Push.
Yeah, push.
Or
A pull.
sure. Yes.
Okay, it took some coaching, but force is essentially just a push or a pull. So then I asked people, what forces are acting on you right now? Most could identify a downward gravitational force towards the center of the Earth, but then things got a little bit hazy.
Can you tell me about the forces on you at the moment?
Well, probably there's a big force downwards towards the center of the Earth.
Which is?
That's gravity, what we call gravity, I guess.
Well, the gravity of Earth.
Where is it? How does it act on you?
Well, it keeps me on the Earth. I don't fly away.
I would be standing on the Earth, and it's pulling me down and making sure that I'm stuck to the Earth. Yeah. Okay.
Nearly 350 years ago, Isaac Newton came up with 3 laws of motion that govern how everything moves. They're 3 pretty famous laws of motion. And they're not very complicated, but if I told them to you as clearly as I can, you would think that you're understanding them, but I think you wouldn't. And the reason is, everyone has ideas about physics and about how objects move before they're ever taught anything in a science classroom. So rather than tell you Newton's 3 laws of motion, I would like to tell you Derek's 3 incorrect laws of motion, which are the ones I think you're actually thinking. So, Derek's first incorrect law of motion is an object with no unbalanced forces acting on it will naturally come to rest. Derek's second incorrect law of motion is that an unbalanced force causes an object to move with a constant velocity. We could express this in an equation where the unbalanced force F equals the mass m times the velocity v. So, if you double the force, the velocity also doubles. It's just like being in a car. As you press on the accelerator, you increase the force on the car, and therefore you move to a new, higher constant speed. Derek's third incorrect law of motion is that larger objects apply larger forces to smaller objects. When a large truck slams into a car on a highway, the force of the truck on the car is much greater than the force of the car back on the truck. Or, if you think about the Earth and the Moon, the force with which the Earth attracts the Moon is greater than the force with which the Moon attracts the Earth. But remember, this is an incorrect law of motion.